Welcome to this webinar on how to test without defined requirements. My name is Randy Rice. I'll be your presenter today, and I'm glad you could all show up. Today's January 23rd, 2014, and I really do plan to keep this as close to 30 minutes as I can. I know there's a lot of information I have here, but I will do my very best. We will be posting the recording shortly after the session, and also it'll be posted up on my YouTube channel, which if you haven't checked that out yet, by the way, I hope you do, because there's a couple of playlists out there. This will start the formation of the second playlist of the how-to series. I have the conceptual series and foundational series out there already. You'll also be able to get the slides on my blog, randallrice.blogspot.com, and I'm going to put them up on SlideShare as well. Now, if you want to know when the next webinar is going to be, just join my newsletter list or like my Facebook page. We'll get into that at the end of the session. I'm reachable by just about any means known to humankind. So, but I put the word out as many ways as I can, as many places as I can. But if you're on my newsletter list, you will get it for sure. And I promise not to spam you. Well, once again, my name is Randy Rice. I've been in building and testing information systems now for over 34 years. I guess it's closer to 35 or 36. But anyway, I'm a fully certified advanced level tester, and also to get that you have to get the foundation level. But I hold all three advanced level certifications from the ISTQB, the Advanced Test Manager, the Advanced Test Analyst, and also the Advanced Technical Test Analyst. For 5 years, I was chairperson of QAI's testing conference from 95 to 2000, and it was my honor to co-author with my mentor, Bill Perry, who was the founder of QAI, the two books, Surviving the Top 10 Challenges of Software Testing and Testing Dirty Systems, both of which you can get out on Amazon. By the way, the Top 10 Challenges book is now in Kindle format for $10, so that's kind of cool. And people say, well, you wrote it in 97, it's out of date. Well, not really. If you look at that, probably about 90% or more of it still holds true today with the people issues. And also, I'm the principal consultant and trainer of our little company, Rice Consulting Services, here in Oklahoma City. So I feel like I'm making this really bold promise, kind of like lose weight instantly or easily, like in the sign. I took this picture, by the way, close to where I live. And the thing that's funny about it is this little part in here, without no exercise. That's what caught my attention about the sign, and the sign didn't stay up very long. I guess obviously you don't have to know English very well to do this either. So the problem, at least as I see it, with requirements, as I talk to people about their testing methods, and as I teach classes and things, a lot of people talk about requirements-based testing, and there's kind of this built-in expectation and assumption, I think, like with test automation, that everybody else but you is doing it. But I talk to people about requirements-based testing and say, well, how good are your requirements anyway? And that's kind of when we start talking about, well, they're not really very good, and I do have a hard time getting them. And I would say it probably ranks about number 3 right now in my top 10 challenges list of software testing. It's just the quality and availability and even inadequacy of requirements. But the real problem is that requirements do have flaws. It's like anything else. It's going to have defects in it. And I've never seen a perfect one. There's always like something else you could write about a requirement. People will tell you the wrong things. You won't talk to everybody, and therefore you'll only get partial input. There's just a whole slew of things that can be causes of problems in requirements, and it takes a lot of hard work to do requirements, even to the point of being pretty good. Okay, not even talking about perfection. But that's why we have validation. Once upon a time, someone made the brilliant observation, I believe, that you can build something according to specs but totally miss the objective of what you're building. And so what validation does is a test of something without any regard to the requirements. It focuses more on the real-world usage of someone in a particular situation to do something with the software or the application. If you looked at all the major methodologies that have come down the pike over the last 20, 30 years or more, you will notice that many of them try to minimize requirements. They try to get by without them. The great goal at one time used to be cartoons to code, as it was called, where you could go straight from a model diagram to code. Well, the problem with that is that there's only so much you can convey in a model. Now, models do us a great service in giving us a picture of what we're talking about, which is very, very helpful. I like models in software as well. We need those kind of things, but they don't convey the business rules. They don't convey the must-haves and the should-haves and all that. Now, the developers, they would probably love to have good requirements too, but they don't have time to go out and get them and interview people and write them down and organize them and manage them and all that stuff. And many companies don't have the role of BA, which would be the key person to do all of this, work with requirements. And finally, users don't like to commit to putting their name on something that, yes, this is what I need, this is what I want, because they may change their mind. And that does happen quite often, doesn't it? Now, a question that I would like to pose to you is, if we don't have requirements in writing, do we still have requirements? And I would say, in the broad sense, yes. We still have requirements. They're in people's minds. They're in shared expectations. They're in individual expectations of what someone wants or needs. But a little test you can do to validate this is just ask any 2 people or 3 people what they think is important in a certain type of system, like a personal checkbook system, or what's your favorite personal finance system, or what's your favorite iPad app for doing whatever. You're going to see a variety of opinions there based on things like ease of use, performance, security, just overall quality. Now, if I'm the vendor, though, of something, if I'm the producer, if I don't get a requirement in writing, I may just ignore it. I may not feel like I'm obligated to deliver it. It may be totally off my radar. And so if you don't know you need it, and if you don't ask for it, then you're very likely not going to get it. So here's another little picture on the right here, the 2 speed limit signs. I also took this picture in my hometown area. This is around Moore, Oklahoma. In fact, those apartment buildings you see there in the background were destroyed by the tornado that went through. Now, I don't believe they were totally wiped out, but they got roofs taken off and things like that. But anyway, so they were widening this road a few years back, and the first work crew came out and put the speed limit sign 40 had already been there. So they're going to reduce the speed limit because of the work, and so the first crew put the 30 mile an hour limit in, and then but they didn't do anything with the second sign because that was another crew's job to remove the sign. But while these 2 signs were up, I was rather confused as to which speed limit really held. Now, I'm sure had I gotten a ticket for going 40, they would have probably said, yeah, well, you were expected to follow the lower one, but still, I always think of this picture when I think about ambiguity and conflict in requirements. Now, don't get me wrong, I'm still a big fan of requirements. I think we need them. If we don't have them, we're going to be in a lot of trouble. But the other side of that question is, yeah, they're important, but the reality is we don't always get them. So what do we do as testers to deal with this? Oh, I see. Little Johnny has a question here. Doesn't Agile solve these issues? Well, no, it really doesn't. A lot of people think Agile solves the requirement problem because instead of having a lot of things on paper, you build things and then you see if people like them or not. If they don't, you rebuild And you keep doing that, rinse and repeat, until it finally reaches something that someone likes. Kind of like this apartment complex made out of RVs. We put little pieces together. Well, the problem is, if you don't know what you're building or testing, no method or no tool is going to be successful in getting you to your goal. That's kind of a paraphrase of a quote from Jerry Weinberg, by the way. Now, user stories and use cases are fine to help fill in the gaps of procedures and who needs what and why, those kind of things. But they're not a complete substitute for good requirements that will get into things like business rules and the non-functional attributes of the application and those kind of things. And then think about this. Think about, let's say you're testing commercial off-the-shelf software. You may have requirements for what you need in the software, and I would say actually that's kind of rare that people define those in writing. But you certainly don't have requirements for what the vendor used to build the application. So you don't know what the requirements were for creating the image in Adobe or those kind of things. Another thing too is that, going back to this idea of validation again, that kind of testing, like you would be doing in user acceptance testing, really should be based in the real world as opposed to the paper world of requirements. Now, this V diagram, if you go out to the web and you go do a Google image or Bing image search or something like that on V diagrams, you're going to see hundreds of different versions of V diagrams. You're going to see the W diagram, you're going to see the X diagram, the Z diagram. Well, the only reason I'm showing this is to show that I show mine in a bit of a different way. I'm not saying it's the only way to show this, but this way makes sense to me. That when I do acceptance testing, I'm not validating requirements as much as I am validating the business need that the requirements should have been based on. So in the nice, clean, ideal world, the requirements are based on the business need. And then the design is based on the requirements, and the code is based on the design and the requirements. But if we get off at any point in this chain here, then we're in trouble. If we start writing requirements, for example, without a firm idea of the problem we're solving, and by the way, let me just ask, how many times have you been in meetings just to discuss the problem you're solving? And I would suggest not many. You can see it's really easy to get off track. We define solutions for things that aren't even problems. And so the acceptance test, I think keeps us grounded in the real world. Okay, now, once again, it's kind of unusual to see it shown this way, but this is the way that I teach it, and this is the way that I think makes the most sense. So here are the 6 ways we're going to go through here real quickly. First of all, our user scenarios. Then we're going to talk about usage patterns, generic test conditions, which would form the framework of something like error guessing, generic functionality such as add, change, deletes, and these are the things that you can see in nearly every application. Common functionality. We're also going to talk about defect-based techniques for testing, as well as exploratory testing. So there's a mind map that I've created for this talk, and you'll see it on my blog as in one of the links, and it's on the final slide. But I really do like mind maps quite a bit. And at this point, I'm going to kind of switch over here, and we're going to look at the mind map for this. And this is based in a tool called FreeMind. Now, FreeMind is a free tool. It's for mind mapping. I like XMind better, but I just had this one going, and so I just built the mind map in this. But see, you can collapse your mind maps. You can expand them. You can collapse them at just about any point up here. Like for user scenarios, we'll see the benefits, the issues, the oracles, testing generic functionality, the upsides, the downsides, the oracles. And so it's kind of interesting to use these for all kinds of things, including your test strategies and test planning. It's a pretty handy little tool. Once again, that's FreeMind. I think if you put in freemind.org or just Google FreeMind, it'll take you to the site where you can download that. Okay, so one other thing as we get started here, and that is fleshing out the idea of a test oracle. Now, a test oracle is just a way to know if a test has passed or failed. It's your pass-fail criteria, basically. And it's what you compare to know if some kind of behavior that you're seeing is correct or not. Now, this could be a person. It could be a document like a training guide or something, a user guide. It could be like another system. If you're building a new system, maybe you're running some calculations through it and you're comparing to what you got in the old system. So maybe your old system is the test oracle. So every technique that we use, should have a test oracle so that we'll know what to look at for correct results. And see, that's what gets so frustrating about this question of requirements. Someone throws something at you to test. Well, they may not throw it literally, but they give it to you to test. And your first question is, okay, what's it supposed to do? And they may give you a brief, verbal, quick idea, but there's a lot of detail in the functionality. How do you know? So I'm going to go through some techniques that maybe can take us there. The very first one is my favorite, actually, user scenarios. My experience in this is if you understand the user processes and the business process flow and those kinds of things, you can cover a lot of tests very, very quickly by starting at the top of your understanding and then working down from that. Just as kind of an example, let's say that we're testing an accounting system and you have accounts payable, receivable, collections, reconciliation, and reporting. And then underneath receivables here, you have like billing and penalty application and reporting. So let's say we want to focus in on the penalty application to test that. Well, we draw a little flow chart, let's say. And by the way, you can draw any kind of chart you like. It doesn't have to be a flow chart. It can be a decision tree or whatever. And we come up with this basic flow chart. And if we were to break out a few of the scenarios here, by the way, we have 4 decisions with 2 answers each, which would give us 16 possible ways to go through this process. Now, we probably wouldn't be able to get through all 16 for everything. What I'm saying is get through all processes, all scenarios for everything. But let's look at scenario 1. This is the one in red. We're going to run the aging report, run the past due invoices. If any accounts are past due, then we review those invoices. If they look okay in terms of correctness and all that, then we go this direction. If they don't look okay, then we fix the problems and repeat. So scenario 1 is kind of like a fixed problem loop here that we would want to test. And you could take the same idea with any of these. Now, it's up to you, but you can put these on a script if you like, or describe them basically any way that you like. But one thing you have to give real thought to is, what am I going to put through the process? Because the process just tells you what to do. You need some data for it to act upon. So let's think about what would be the appropriate person or thing to put through here. And it would probably be a customer that has an account. Okay? So let's make the customer our primary test entity, and then break those down between new and existing customers, and then perhaps regular and preferred for each one. Now, we could also drill down, like have some customers not overdue, some 30 days past due, some 60 days past due, and so forth. Now we're getting down to the level of test cases. Now, what I've just shown you is a way that you can sit down in about 3 hours or less and design a lot of tests, probably as many as you need for your test. And once again, you don't need to know requirements. You don't even need to know how the system looks. Now, at some point, if you script it, yeah, you may need to know how certain things are done for the purpose of scripting. But for the general thing that you're trying to do, like, if we go back here, like processing invoices for people over 90 days past due, you're concerned with what you're doing in your business for that, okay? All right. So your oracles in this method are users, trainers, BAs, managers perhaps, but you can also look at things like process guides and training manuals as well. Now the number 2 technique is usage profiles. And this is kind of interesting because you design your test based on the type of users you expect, like the novice user, the expert user, the clueless user. Kind of joking there, but you know, we've all experienced that, I believe. The disabled user. Perhaps you may have someone with sight impairments, or they have dexterity impairments. Or maybe you might have the demanding user who they want everything in the application. So this is a good way to get a variety of different user perspectives. And the neat thing about this is you can take any of the tests that we're talking about in this webinar and you can adjust them based on the user personas. You might want to make them easier for the novice users, more difficult for the expert users. But it's a good way to kind of get some perspective. Now, you may not have time to test all the personas, and plus you may not be aware of all the different user types that you have. Now, our oracles here would be users and trainers and managers and such that could clue us into the types of users that we have. And I would suggest to you that your list isn't probably going to be real long. You're probably going to be able to categorize these in about 10 user groups or less. Now, number 3 would be generic functionality. These are the things that you do in just about every application of the type that you're testing. Things like add, edit, delete, search. These are very transportable. Now, the risk here, though, is that you may miss some very specific functions in your common function checklist or grid, as we're going to see. And so you need a way to go back and pick those up. And you can do that through, once again, the process test or exploratory testing or some other means. You can use a collection of these methods and still get a pretty complete test. My friend Greg Pascal in Dallas, he has a website, gregpascal.com. A few years back, he came up with this approach called the Minimal Essential Test Strategy, or METS. And he even made a little iPhone app for this. And it's based on 2 views of the application. You have the physical items. These are the things that you interact with. Now, as you can tell from the picture, this is ideal for mobile testing. Anything with a touch screen, but you can also apply it to things like web pages and those kind of things. Think about this. These are the things that allow you to get to the functionality, but they're not the functions themselves. These are just the enablers of functionality. And they will have various levels of criticality, such as the idea that, let's say that we're testing images. Well, a critical thing about images is that they're present. High is that they're correct. Medium is that they load quickly. And the low priority here, or criticality, is that the image is clear, is at a nice resolution. So we have this physical test grid in METS, and it's based on categories. Like, let's say we want to test a website. So we have web pages, graphics, forms, and you have the critical things for each of those, the high things for each of those, the mediums, and then the lows. And like the page completes loading is a critical thing. The graphics completed loading within the same time frame would be a high priority. If we go down here to forms and medium submitted form contains drop-down menu selections. So you get the idea. Now, think about it this way. Every website you test could probably use this grid. And so now you're not redesigning the test every time. You have something a little better than a checklist. Although this kind of resembles one, it doesn't show you the expected results, but it does kind of indicate like radio buttons are functional. Not only are radio buttons in place, but they are functional. They are functionally correct. Now, for every item that you show, you can also estimate the time and the severity for those. So, like in the case that we just saw, page completes loading, it's a critical priority item, and we could probably test that in about 1 minute. So we're saying it's the severity. It's got an impact, severity impact of 1, where in this case, 1. Let's see, 4. Yeah, 1 is the most critical. 4 is the least. And this. So you can see that you kind of have that risk view there. Now the functions, these are the things that the application can do. They're the create, the cancels, the queries, and those kind of things. So like in a shopping cart function, it's critical that an item can be placed into the cart. Now you would also want it at a very high level of importance to be able to put several items in there if you want to make money. Also, medium is, do the items consistently carry through the purchase session? It's a stateful kind of transaction, so they need to be there throughout your session. You don't want to lose items out of your basket just randomly. And low are the related products shown. This is not an essential, but it could get you some other orders perhaps. So we created a grid for this one. A category of accounts, shopping cart, product catalog, transactions, searches. Same thing. Creating an account is possible. Can the user change account details such as the shipping address? Can a user delete an account is the medium. And low would be, is the user modified when they must log in. So these are just things. Now you need to take these spreadsheets and adjust them for your own test, because you may have different views of the level of criticality for each of these. But here's the other cool thing you can do with this, is that you can do some estimation, and each item is assessed by its level of direct testing, that is, testing the thing itself, the function itself. Maybe that was coded or changed or something. The related testing would be things that you know would be directly impacted by the change or the new function. And regression testing are those things, of course, that you do not want to change or see act any differently. So you'll see over here on the right now we have a couple of new tables and 3 columns on this one, direct, related, and regression testing, and we just simply mark one of the 3 for each test that we're doing. And then we move the time required over into the column D, R, or B. And I suppose if you really wanted to streamline this, you could just eliminate this third table and just put the number in here. But anyway, it shows how much time you plan to spend in minutes for direct testing, how much for related, and how much for regression. And it's got a little time budgeter in there that you can use as well. So our oracles for generic functional testing would be users, developers, trainers, business rules, and checklists, and things like METs to kind of help us know what we should be expecting. Now the number 4 item are the generic test conditions. This is the error guessing part. Checklists are usually a big part of this. Just like the METs list, these are very transportable. And just like the previous one, you may miss some specific functions. So this is just kind of like a basic test, and then you may have to add some specific test into test calculations and such. But you'll see here, like functional error conditions, I want to reject invalid data formats, invalid data ranges, invalid data types, such as alpha in a numeric field, blanks in a numeric field, and so forth. Now, I'm also going to, in the download pack for this webinar, include my unit test checklist. Now, keep in mind, this is for unit testing, a very low-level test, but wouldn't it be great if all these things were correct coming to you as a tester? All field labels and numbers are present and spelled and identified correctly. Do drop list boxes, drop down lists contain all required inputs? So it's just a checklist, yes, no, or not applicable. And we have this not only for the interface, but for date handling, reporting, searching, all those kind of things. It's a 2-page checklist. And if nothing else, for unit testing, this could improve the process greatly. Now, your oracles here are going to be users and trainers and developers, business rules perhaps, your checklist, maybe troubleshooting guides as well. Now, the number 5 technique is defect-based. And this is where you use the data from your past defects to look for defects in new applications. So it basically builds this feedback loop that we often miss, where we just keep making the same mistakes over and over again. We keep finding and fixing and creating in this weird cycle. And so if you can break the cycle and start testing these early, and even making sure you don't create these defects is even best. But it is a great way to get the value out of defects. You know, every time you find a defect, you should be thinking about, is this something that I need to test in the future? Now, here's the thing. The ticket in the door to this one is you have to have good processes to capture your defect data, and you have to have decent measurements. So, like, you need to be able to categorize defects and to understand what the true nature of the problem was and how they got resolved and so forth. Now, sampling here is helpful. And what I mean by that is once you start seeing a defect in a certain area of your application, then start looking around it, because you'll typically find others, because defects do tend to cluster, or at least they seem to. Now, your oracles here would be developers, users, maybe past defect reports and resolution to see what the correct behavior of something was. And then finally, number 6 is exploratory testing. Now, this is not just ad hoc testing, but this is testing and learning at the same time. However, we don't have any predefined cases or scripts. This may be done in more of a free-form way, or it could be done in more of a session-based way, which is a little bit more managed. But it does tend to be quick, and I'll just say that its effectiveness depends a lot on the individual tester and their experience, their ability to think critically, notice odd behavior, to think creatively, try to find unusual things. Now, at this point is where I kind of have concern or, questions that kind of bother me about exploratory testing, even though I'm not against it and I use it and I teach it and all that. The thing that bugs me the most about it is I might find something that looks like a bug, and I spend all this time tracking it down and talking to people about it, but they come back and they tell me, no, it's really a feature. It just looks weird. So now this was not my original picture. A friend of mine sent this to me. But whoever drove this vehicle must have either been a developer or a tester on the bug, is it a feature? So BAs, users, other testers, and developers can be helpful in helping you understand the results of exploratory testing. Now, here's the resource list. I have an article also on this on my website, How to Test Without Defined Requirements. You got the URL right there. Some great free graphing tools, YAD, Glyphy, FreeMind, XMind, CTEXL. By the way, CTEXL used to be one of my favorite tools. Now, not so much, because it's a classification tree editor, and it used to generate test cases for you also for free, and do it in pairwise and all kinds of cool things, and you could export it to Excel. Well, they took all the cool stuff and they put it into the Pro version now that costs about $2,500. But if you want to draw a classification tree, which may or may not be helpful to you. The free version is still out there. You can get it, but you can do a classification tree in either one of those first two as well. And then I have some checklists for the error conditions and unit testing that you can download, as well as the MET spreadsheets. You can go to my site or you can go to Greg's. And if you want the mind mapping or the mind map that I drew for this, I have it in PDF version as well as mind map file version for FreeMind. So you can go to that one as well. Now, if you have any questions at all, please contact me. As you can see on this slide, once again, you can contact me in any number of ways. Come to my site, contact me from there, write me an email, connect with me on Facebook or LinkedIn or Google Plus, any of these, tweet me, whatever. And I would not only love to hear your questions, but I would like to get your feedback, and I would like to know what you maybe would like to see as a new presentation, something for next time, for next time's webinar. I'd love to know what's of interest to you, so I'm presenting the things that are of most interest. Okay, well, that about wraps it up for today. I hope you have a great day. And once again, I want to thank you very much for being here and hope that you can make it for the next webinar that we have in February.